All right, welcome back to the session. So let us now talk about Newton's law of gravitational attraction. So I wanted to start on this one because in the previous session, I just ran through it fast. I want you to understand what it means and the other things that are needed. All right, so like I said, Newton's law of gravitation simply discusses the forces of attraction between two objects. Yeah, so these two objects these two objects will have a distance or between them. I mean, let me say they'll have the distance between them, which we're going to call R. So, okay, let me just put up the notes so that you know what I'm talking about. So we're gonna have two objects. Let's say you have this object, object A and object B. So object A can have the mass M1 and then object B also have a different mass M2. So if this is what you have, and then you have these two objects, they have a distance from their centers. This distance from their centers is called R. And then the formula for Newton's law of gravitational attraction is given by a force, which is the force of attraction is equal to Newton's law of, the Newtonian gravitational constant times mass 1 times mass 2, and then everything divided by the radius squared, or rather the distance between them squared. So this is what it means. Now imagine if you have one of these objects is the Earth. Maybe let's say this object will consider it to be, maybe to be what? Maybe a human being. Okay, let me draw something here. If you have an object like this is the Earth. So this Earth has the radius from this distance up to there. This is the radius of the Earth. And then just immediately after this point, there is a human being standing. There's a human being standing. Then we want to find the force of attraction between the Earth and the human being. So how do we find this force of attraction? So in a similar way, when we use Newton's second law, we know to say the force is equal to mass times acceleration. Mass times acceleration. But in this case, we're going to consider gravity, meaning we're going to consider the weight of a person on Earth. So to find the weight of a person, we know to say weight is equal to mg, which is mass times the gravitational acceleration. Yeah. So, or acceleration due to gravity, that's g. So while there's F there, I'm going to put mg. So I'm going to put mg while there's F, and then we also have this being equal to Newtonian gravitational constant, and then m1. I'm going to put this mass for a person to be my m, and then the mass of the Earth, I'll name it me. So we have two masses, m1 and m2. So one m is m, and then the other m is me. So I'm going to write them here. We have m, which is the mass of a person, and then we also have me, which is the mass of the Earth. Then the radius between the center of the Earth to the center of mass of this human being, we're going to get it just to be the radius of the Earth. Why are we saying it's just equal to the radius of the Earth? We consider the radius of this object or this particle to be negligible. So we're just going to get the radius of the Earth as our radius. So if you put it there, because when you compare the radius, let's say if you get 1 meter, if maybe a person is 1.5 meters. So if that person is 1.5 meters, and then you get half of 1.5 meters, that is, I think, 0.75. Yeah, so 0.75 compared to the radius of the Earth, which is approximately 5. Let me just check it. Yeah, so you compare the radius of the Earth to the radius of the human being. You consider that you discover that the radius of a human being is close, or it's nearly negligible. Look at the radius of the Earth, which is 6.37 times 10 to the power 6 meters. So this is about 6 million. Yeah, so when you compare 0.5 meters to 6 million meters, the 0.75 is nearly negligible. So this is what I was trying to talk about here. So we just consider the radius of the human being to be, I mean, the radius or the center of the radius, or rather the center of mass of a human being to be negligible. So this distance will be considered to be negligible. The distance from there to there will be negligible. Hence, we just get the radius of the Earth and replace it where there's arrow there, and then we square it. So when you look at this m and that m will cancel, meaning the formula for gravity will simply just be equal to the Newtonian gravitational constant times the mass of the Earth, then everything divided by the radius of the Earth squared. So once you compute this, you put the radius of the Earth here, which is a constant, you put the mass of the Earth there, which is constant, and then also you put the gravitation or the Newtonian gravitational constant there, which is also a constant. If you put all those constants there, the answer that you're going to get this side will will simply just be 9.81 meters per second squared, which is just the G that we always use here. So this is just the G that we always use. All right, so let's quickly move on to the units, units of measurement. So let me go through the notes. In statics, we often need to compute the weight of the body, which is the gravitational force acting on it. And then this computation depends on the law of gravity. The law of gravitation formulated by Sir Isaac Newton. So this is the formula I was talking about, where F is the mutual force of attraction between two particles. Then G is the universal constant between, or known as the constant of gravitation. And then M1 and M2 are simply just the masses of the two particles. Then there's also the R, which is the distance between two centers of the particles. Yeah, so the universal constant of gravitation, which is G, is simply just 6.673 times 10 to the power negative 11 newtons meter squared per kg. So this is what I talked about. Yeah, so if you have the first object there with the mass M1, the other object with the mass M2, then they all have, we're trying to find this force of attraction between two objects. You simply get also the distance, which is from their centers, the distance between them, starting from their centers, from their midpoints there, which is R, and then you plug them in the formula. Then you get the force of attraction. Okay, so the force F exerted by the Earth on a particle is defined as the weight of the particle, which is W, which is M, is equal to mg. Then for a body of mass m near the surface of the Earth, the gravitational attraction F on the body is equal to the weight. So when an object is closer to the Earth, its gravitational attraction F on the body is equal to the weight. So this is what they mean. I explained this. So what is F this side? They've just replaced that part with mg. And then this m and m1 are equal, so they are going to cancel this and that. And then m2 simply just be the mass of the Earth, which is a constant. We know to say the mass of the Earth is 5.97 times 10 to the power 24. And then M2 is considered to be equal to this M there, and hence it cancels. Then the radius of the Earth, which we're going to replace there, is simply just 6.37 times 10 to the power 6 meters. And then the gravity is therefore found to be 8.1 meters per second squared. Okay, so let us quickly move to the system of units. Yeah, the systems of units. All right, so these are also some of the straightforward things that you already know. You did them in physics, so I'm just going to run through them. Yeah, so I'll be taking time to explain what we're going to start learning in the next slide. Otherwise, this was just an introduction. So I expect most of you to know what I'm trying to talk about right now. Okay. At least you have an idea of what I'm talking about. Okay. So it's just a pity that most of us have joined late. Anyway, don't worry. I'm going to send the recorded session to the group so that we can have a revision of what we learned in the first session. And then this is the second session, by the way. So most of you have missed the first part. And yeah, like I said, I always record the session. So I'm going to send the recorded session so that you can have a revision, or you can have you can go through what we've already discussed with your friends. Okay, so let's proceed. So the units of measurement. So when you talk about the units of measurement, we're simply talking about the SI units and other measurement units. Yeah, so there are basically two major systems of units used in the mechanics of, in mechanics rather. Yeah, so we have the SI units, also known as the metric system, and the English unit. Yeah, so there are basically two. They're what we call the SI units and the English units. You learned this in physics, so I don't expect people to be lost on this. Yeah, so like I said, in this slide, whatever that I'm explaining are simply just basics. Most of them, they will not even come in your test or in your exam. They're just there for you to have the basic concept of what statics is. But on the units, you need at least to pay attention because you'll be dealing with units almost every day. Every time you're solving statics, you'll be given certain things or certain figures in units that needs to be converted to other units for you to solve a question. Yeah, so you need to at least pay particular attention on this. Yeah, so the English units are also known as the customary or imperial systems, which I believe most of you already know. Okay, so this is what I was just talking about. There are two major systems of units used in the mechanics. So we have the SI units, which I said they are also known as the metric units. And then there are also what are known as the English units, which are also known as the customary or imperial systems. Yeah, so some of the examples are here. Yeah, so we have the SI units here. These are some of the examples of the SI units. Don't worry, I'm going to send this slide to the group so that you can just go through them on your own. Yeah, and then we also have the US customary units. So mostly we use the SI units to solve questions. So if you've been given any customary or imperial system of units, you have to convert to, you have all right, so there was a network problem. Okay, so let's continue. Like I said, these units are simple and straightforward, so I don't expect most of you to get lost on how to convert these things. They are simple and straightforward. Okay, so let's quickly move on. Let me just run through the SI units. We know what these units are. So let me just send the slide to the group so that you can go through. So all these things are simple and straightforward. I've also put some examples in the slide which you can go through and see how you can convert some of these units. Otherwise, some of these will not even be used. What we're just going to be using throughout are the SI units. Okay. So all these are simple and straightforward. So we have an example here which says the magnitude of a velocity is given as velocity is equal to 30 miles per hour, and then they are telling you to convert that to feet per second. So this is also straightforward. So we have 1 mile is equal to that is standard, and then you also have 1 hour is equal to 3,600 seconds, and then you just have to put them in this format. I'm sure you did this in physics. This is straightforward. Yeah, so whenever I'm solving questions, I'll be showing you how to do this. This is straightforward. Yeah, so I don't know if I should solve it, but I think this is straightforward. I'll send you the slide, you go through it. Unless you have a question on some of these questions I'm putting in this slide, that's when you can simply just screenshot it and send it to me. Then I'll explain it to you either in a voice note, or if there's need for me to come back online or to form a link just specifically for you to explain a particular question, I'll do that. Yeah, so what I want is for everyone to understand. Okay, so this is straightforward. Or let me just solve it for the sake of other people. So we know to say 1 mile is equal to 5,080 feet. Then 1 hour is equal to 3,600 seconds. So if you want to solve such a question, we have been given to say we are converting 30 miles per what? Per hour. So I'll make sure that whatever that I'm going to multiply this side to, or whatever that I'm going to multiply to this 30 miles per hour will be cancelling with either the numerator or the denominator. So I know to say 1 hour here, I'll put my, okay, let me start first by cancelling what? Miles. So if I want to cancel the miles, I'm going to draw the division line there, and then I'll make sure that this mile will be down so that it cancels with that. So I'm saying 1, or what I mean is that I'll put 1 mile down. So 1 mile is equal to what? 5,280 feet. So this is what I'm going to do. And then 1 hour, for it to cancel with this hour, it means that it has to be on top. It has to be the numerator. And then 1 hour is equal to what? 3,600 seconds. So these are basics. These are just introductions. Like I said, whatever that you did in physics were just introductions to statics. So I've decided to go back a bit to physics so that you can have a recap of what you learned in first year. Yeah, so whatever we're going to start doing, starting from the next lesson that we're going to have for statics will be purely statics. We'll start solving questions, meaning we're just going to be applying most of the concepts that you learned in first year to solve questions. But of course, I'll teach you how to understand questions so that you shouldn't be getting stuck like the way you used to get stuck in physics when you see a tutorial sheet. Yeah. Okay, so we can see that this hour and that hour will cancel. Then this mile and that mile will cancel, meaning we're just going to remain with 30 times 5,280 feet. Then everything divided by 3,600 seconds. So you can see that what we've remained with this side is what? Feet per second, and that's what they want. So this is just a matter of multiplying this using a calculator, and then you get the answer. Okay, so this is what I made. You can see that this hour and that hour goes, this mile and that mile goes. We're just going to remain with feet and seconds. Then you multiply the remaining figures. All right, so we also have, okay, so this is the solution after doing the multiplication. So we also have another example. It says determine the weight in newtons of a car whose mass is 1,400. Convert the mass of the car to slugs and then determine its weight in pounds. Okay, so the first thing that we have to convert, we've been asked to determine the weight of the car in newtons. So how do you do that? We know that weight is given by what? Mass times gravity. So the mass of the car is 1,400 kg. We're multiplying this with what? 9.81. Just converting this to to newtons. So this is 9.8 meters per second squared. So when you multiply this, you're getting your weight to be, when you multiply this and that, I don't have a calculator with me right now. Hence, let me just put up the solution. So this is what I was talking about. When you multiply 1,409.81, you're getting your answer to be 13,730 newtons as your answer. So this is your answer. Then the other question is asking us to convert the mass of the car to slug. So we know that the conversion factor for slugs to mass, for one slug to kg is simply just 14.59. So this one is straightforward. You just have to do the division there and get the answer, which will give you what? 95.9 slug. So all these, I'm sure you did them in first year, semester 1. So this is just a revision. We've not yet started learning statics, so I'll be taking time to explain statics. So some of these concepts that you did in first year, I'll just be doing them fast. But if you have a question, you've not understood anything, feel free to ask me a question. There's an option of raising a hand there on your screen, so you can just tap there, and then I'll see from here, and then I'll give you a chance to ask the question. Then I'll respond to you. Okay. So, and then we find the weight in pounds. We know that when you're converting the weight, the slugs to pounds, you simply just have to multiply them by 32.2, and then you get your answer in pounds. Okay. So these are some of the recommended books that you need to have. Yeah, so most of you that have paid, I'm sure I'm going to form a new group where I'm going to put all those that have paid. So I'm going to send all these books to the group so that you can have them. Yeah, so that you can have them, you can be going through them. I also have some of their solution manuals, so I can give you, I'm sure, let me say I will give you together with their solution manuals. And I'll be giving you some exercises to test your understanding as we proceed. So we have Miriam, Clegg, it's also very helpful in statics. Then apart from that, there's also this one, there's also Bear Johnson. Then apart from that, there's also, I've forgotten this book. Yeah, anyway, I'll send it, which is also a very good book and it's easier to understand. All right, so thank you very much for attending tonight's lesson. Yeah, so those that are ready to make payments so that we can proceed together next time, feel free to contact me. We'll discuss, we'll see how we can help each other. Yeah, so even the other courses will proceed. So today is Friday. So next week on Monday, we're starting with material science. And the other, next week on Monday, material science. Then Tuesday, Wednesday, we're doing mathematics, engineering mathematics. And then on Friday, we'll be doing statics. So I've sent the timetable to the group. You can take a look at it. And then we can be following like that. So those that have their monies ready, they can contact me. We can, I'll send you the lines which you can use to send the monies to. All right, so thank you very much for watching, for attending tonight's lecture. If you have any questions, feel free to ask. You can either text me on WhatsApp or you can ask right now before I can end the meeting.